Welcome students, myself Kale SL, रयत शिक्षण संस्थास RBNB कॉलेज रामपुर. 11 Science Mathematics Part 2, Chapter number 1, Complex Numbers, Exercise 1.4, Lecture number 10. In the previous video lecture, we have completed question number 1 and question number 2 of the exercise 1.4. In this video lecture, we will see here question number 3 and question number 4. So let us see here question number 3. If omega is a complex cube root of unity, find the values of. First problem is omega plus 1 upon omega. Second one is omega square plus omega cube plus omega to the power 4. Third one is 1 plus omega square to the power 3rd, and fourth one is 1 plus omega into 1 plus omega square into 1 plus omega to the power 4 into 1 plus omega to the power 8. Now first problem. Solution of the first problem. Let omega plus 1 upon omega, it is equal to, we write this as this omega as omega upon 1 suppose, and 1 upon omega. Here denominator of omega is 1. Now we take the addition. How we take the addition? Omega into omega, that is omega square, plus 1 into 1 divided by 1 into omega. Now here we have given that omega is a complex cube root of unity. Means we know that omega square plus omega plus 1 is equal to 0. We have seen in the previous lecture. Omega square plus omega plus 1 is equal to 0. Now here omega square plus 1. So from this equation omega square plus 1, carry this omega to the right hand side. It is minus omega. And so it is equal to minus omega upon this omega. Omega get cancelled, so the solution is minus 1. So solution of the first problem is minus 1. Now second problem. Second here, consider omega square plus omega cube plus omega to the power 4. Now here take omega square common. So omega square in the bracket, here 1 plus here omega plus here omega square. We take omega square common. So here 1, here omega square outside. So here 1 omega remain, here omega square, and here omega square remain. Now here 1 plus omega square, just we have seen, since omega is a complex cube root of unity, omega square plus omega plus 1, it is equal to 0. We know this. So 1 plus omega square, 1 plus omega square, value is 0. So omega square into 0, so it is equal to 0. So the solution of second problem is 0. Now third problem here, 1 plus omega square to the power 3. 1 plus omega square to the power 3. So it is equal to, since we know that 1 plus omega square is equal to 0, since omega is a complex cube root of unity, omega square plus omega plus 1, it is equal to 0. Now here in the bracket 1 plus omega square. So 1 plus omega square. So carry this omega to the right hand side. It is minus. When we carry on the right hand side, it is minus. So we put the value of 1 plus omega square as minus omega and to the power 3. Okay. Now here minus to the power 3 is minus and omega to the power 3. And also here omega cube is equal to 1. We know this. So here we write minus 1. So the solution is minus 1. Now here fourth problem. 1 plus omega into 1 plus omega square into 1 plus omega to the power 4 into 1 plus omega to the power 8. We have to find the value of this. And omega is a complex cube root of unity. Since omega is a complex cube root of unity, we know omega cube is equal to 1. So here first bracket as it is 1 plus omega, second bracket 1 plus omega square as it is. In the third bracket we write here 1 plus this omega to the power 4, we write omega cube into omega to the power 1. In the second, in this bracket we write here 1 plus omega to the power 3 to the power 2. 3 2s are 6 and 2 remains, so we write here omega square. Okay. Now we put the value of omega cube as 1. So we get here 1 plus omega into 1 plus omega square into 1 plus, here omega cube is 1. 1 into omega, that is omega. Again here 1 plus, here omega cube is 1. 1 square, that is 1. 1 into omega square, so it is omega square. Now here 1 plus omega repeats. 1 plus omega into 1 plus omega. So we write here 1 plus omega bracket square. Now here this 1 plus omega square and this 1 plus omega square. So we write here 1 plus omega square to the square. Again we use here formula. Since here omega square plus omega plus 1 is equal to 0, we know this, and from this relation we find the value of 1 plus omega. 1 plus omega, so 1 plus omega, carry this omega square on the right hand side, it is minus, so we write here minus omega square to the square. Okay. Then here 1 plus omega square. 1 plus omega square, right? This omega on the right hand side, it is minus, so here minus omega and it's a square. Get it? 1 plus omega, it is minus omega square. 1 plus omega square, it is minus omega. So here it is equal to minus and it's a square, so it is positive, so omega to the power 4. Here also minus square is positive, here omega to the power 2. So it is equal to omega to the power 4 plus 2, that is 6. So here it is equal to, we write this omega to the power 6 as omega to the power 3 to the power 2. 3 to the 6. And omega cube is 1. So 1 to the power 2. 1 to the power 2 is 1. So the value of this fourth problem is 1. So in this way we have completed here question number 4. And now we have completed here question number 3rd. Now we see here question number 4th. If alpha and beta, question number 4, if alpha and beta are complex cube roots of unity, complex cube root of unity, then show that first problem here, alpha square plus beta square plus alpha square plus beta square plus alpha beta, it is equal to 0. And second problem here, alpha to the power 4 plus beta to the power 4 plus alpha to the power minus 1 beta to the power minus 1, it is equal to 0. We have to show this. Now what we have given here, alpha and beta are the complex cube root of unity. We have seen in the previous video lecture, cube roots of unity are 1, then minus 1 plus root 3i divided by 2 and minus 1 minus root 3i divided by 2. These are the cube roots of unity. Further, we call this minus 1 plus root 3i divided by 2 as a omega, and then this is omega square, because square of this is this, or square of this is this root. So complex cube roots of unity are minus 1 plus root 3i divided by 2 and minus 1 minus root 3i divided by 2. And here we have given that alpha and beta are complex cube root of unity, means we have to assume this as alpha or this as alpha and other root as beta. So we take here alpha as minus 1 plus root 3i divided by 2 and beta as minus 1 minus root 3i divided by 2. So here we write, since alpha and beta are complex cube roots of unity so let us assume here therefore alpha is equal to minus 1 plus root 3i divided by 2 and beta is equal to minus 1 minus root 3i divided by 2. Now here we take the addition of these alpha and beta and the product of alpha and beta. So now consider here alpha plus beta. So this is equal to minus 1 plus root 3i divided by 2 and plus here beta as minus 1 minus root 3i divided by 2. Okay. So here denominator is same. We add the numerator, that is minus 1 plus root 3i minus 1 minus root 3i divided by 2. So here plus root 3i and minus root 3i get cancelled to each other. Here minus 1 and minus 1. It is minus 2 divided by 2. 2 get cancelled. So here it is equal to minus 1. So we get here alpha plus beta. Alpha plus beta as minus 1. Now we take the product of alpha and beta. So let's consider here alpha into beta. Alpha into beta. It is equal to, put the value of alpha, that is minus 1 plus root 3i divided by 2 into beta, beta as minus 1 minus root 3i divided by 2. Now here if we observe the numerators here minus 1 plus root 3i into minus 1 minus root 3i means here these are the complex conjugates of each other. So here plus sign and here minus sign. So we use the formula a plus b into a minus b. It is equal to a square minus b square. So here it is minus 1 square minus b means here root 3i square divided by 2 into 2, 4. In the numerator we use the formula a plus b into a minus b, that is equal to a square minus b square, and divided by 2 into 2 it is 4. So it is equal to minus 1 square is 1 minus here root 3 square, that is 3, and I square is minus 1 divided by 4. So we get here 1 minus plus 3 divided by 4. So 1 plus 3, that is 4. 4 divided by 4, it is equal to 1. Means here we get alpha into beta is equal to 1. We get here alpha into beta as 1 and alpha plus beta it is equal to minus 1. Now we solve here first problem, that is we have to show that alpha square plus beta square plus alpha beta is equal to 0. So consider here first LHS is equal to alpha square plus beta square plus alpha beta. Okay, if we adjust here we write like this: alpha square plus beta square plus 2 times alpha beta. We take here 2 times alpha beta minus alpha beta, 2 times alpha beta minus alpha beta means alpha beta. Okay, and now here see a square plus b square plus twice ab. Use the formula a square plus twice ab plus b square, that is equal to a plus b bracket square. So a is here alpha and b is here beta bracket square minus alpha beta. Okay, and now we know the value of alpha plus beta and alpha beta. Alpha plus beta is minus 1. So it is equal to minus 1 square minus alpha beta here 1. So we get here minus 1 square is 1, 1 minus 1, so it is equal to 0, which is nothing but RHS. हेच आपल्याला या ठिकाणी दाखवायचं होतं. So we get here LHS is equal to RHS, hence proved. Now we show here second. Consider here second. LHS is equal to LHS. What is LHS here? Alpha to the power 4 plus beta to the power 4, okay, plus alpha to the power minus 1 into beta to the power minus 1. So we write this as We write this as alpha square to the square plus beta square to the square and plus here 2 times alpha square beta square and minus 2 times alpha square beta square. Okay, we add and subtract 2 times alpha square beta square, and this plus alpha to the power minus 1 beta to the power minus 1, we write it as 1 upon alpha beta, 1 upon alpha beta. And now this is the expansion of, so this is equal to alpha square plus beta square to the square, alpha square plus beta square to the square. Here alpha square to the square plus beta square to the square plus 2 times alpha square beta square, we write alpha square plus beta square to the square minus here 2 into alpha beta bracket square and plus 1 upon alpha beta. Okay, we call this as equation number first. Suppose here this is equation number first, and now we have to find here alpha square plus beta square. Alpha square plus beta square, it is equal to alpha square plus beta square plus 2 times alpha beta and minus 2 times alpha beta, and now this is equal to alpha plus beta bracket square and minus 2 times alpha beta. So alpha plus beta, this alpha plus beta, it is equal to how much? Minus 1. So here minus 1 square minus 2 and alpha beta is here 1. So we get here minus 1 square is 1. 1 minus 2 into 1, that is minus 2, and 1 minus 2 it is minus 1. So we get here alpha square plus beta square as a minus 1. And now from equation 1, LHS is equal to LHS, it is equal to alpha square plus beta square bracket square. We get here alpha square plus beta square as a minus 1. So here minus 1 square. Then minus 2. We put the alpha beta. Alpha beta is 1. Alpha into beta, that is equal to 1. So 1 square. And 1 upon this alpha beta again 1. So here we get minus 1 square is 1 minus 1 square is 1 into 2, that is 2, and plus 1 upon 1, that is 1. Here 1 plus 1 2 and 2 minus 2 0. So this minus 2 and plus 2 get cancels and it is equal to 0, and this is equal to RHS, and therefore LHS is equal to RHS, hence proved. Now see here second again. We have to show here alpha to the power 4 plus beta to the power 4 plus alpha to the power minus 1 beta to the power minus 1 as a 0. So we consider here left hand side, LHS is equal to this. We write this alpha to the power 4 as alpha square to the square plus beta to the power 4 as beta square to the square, and plus we adjust here 2 times alpha square beta square. Why this? We adjust this term because this is the complete square of alpha square plus beta square bracket square. So we adjust here 2 times alpha square beta square, and we cancel this minus 2 times alpha square beta square plus this alpha to the power minus 1 beta to the power minus 1, it is 1 upon alpha beta. Now we write this as alpha square plus beta square bracket square using the formula a square plus b square plus twice ab, that is a plus b bracket square. A is alpha square and b is beta square, minus 2, and this alpha square beta square we write alpha into beta whole square using the rule of indices plus 1 upon alpha beta. We call this as equation number 1 because we have to find this alpha square plus beta square. So consider here alpha square plus beta square. Again here we have to complete this square. So we adjust here alpha square plus beta square as it is. So we adjust here 2 times alpha beta and minus 2 times alpha beta. And now these 3 terms are the complete square of alpha plus beta bracket square and minus this 2 times alpha beta. Now we have alpha plus beta, it is minus 1, so minus 1 square, minus 2 and alpha beta is 1, so minus 1 square is 1, minus 2 into 1, that is minus 2, 1 minus 2, it is minus 1. And now again we take here equation number first, whose left side is LHS, so LHS is equal to here alpha square plus beta square, that is minus 1, so minus 1 square minus 2, alpha beta is here 1, so 1 square plus 1 upon alpha beta is 1, so this minus 1 square is 1, minus 2 into 1 square is 1 into minus 2 and plus 1 upon 1 is 1, so this plus 1 and plus 1 plus 2 and minus 2 get cancelled to each other, so it is equal to 0, which is nothing but the RHS, hence LHS is equal to RHS. In this way we have completed here question number 4. So here we completed whole complex number topic, and we will see the next topic in the next video lecture. So we stop here. Thank you.